Hey everybody, and thank you so much for having me here to be able to do this talk and to tell you guys about Electron and to tell you guys about building a production application with Electron. So I'm going to move on to the next slide here. So browsers have replaced a huge amount of the software that's on our desktop. If you look at Google Docs, if you look at like a lot of the applications that we use today, we go online and we do this through a browser. But the browser has some limitations, and that makes sense. That's what that paradigm is. It wouldn't make sense for that distribution model if it had complete access to everything on your computer. So, so we're kind of left with this gap, which Electron fills. So Electron, this is Chromium and this is Node together. And it's sort of like a browser, but you have these elevated features. It's actually sort of the inverse of the browser. So you can build browsers with it. And in fact, many of you have probably seen Brave, which is a really interesting project by Brendan Eich. And it's probably one of the first browsers that's actually going to support WebTorrent and some of these interesting peer-to-peer protocols natively, which is just going to be incredible. So the question is that can web platform technologies actually compete with desktop applications, with the native technologies that are super smooth and really slick? You know, is Electron just basically a web page inside a window? Well, I noticed you all have your laptops out, so. So I thought maybe we could go ahead and just try this, and basically just echo a string, you know, an onload event on the window with a nice little fat arrow function. The document.body inner text requiring the OS module from Node, calling the uptime function. And the reason why this is actually super interesting, can I turn this off because I feel like it's echoing? The thing that's really super interesting about this and amazing is that you're in the browser. Your document is talking directly to the kernel. You're getting information out of proc, or you're getting information out of whatever it is. If you're on Windows or Mac, you're getting information directly from the operating system, which is very cool. It reduces this whole layer of machinery that you normally need to go from some sort of server to some sort of presentation layer. This is super interesting. So there's really good talks about how it works and that go into a lot of depth. So I'm just going to give you a really high level here, because if you're interested, you're going to go and see the 30 other talks that there are about this. But at a really high level, the sort of 30,000-foot view, that there's a node process. And you start off just like you would run any node program, and I'm sure most of you here have run node programs. You create an index.js or a main.js file, and you start requiring modules. Well, in the case of Electron, you require an Electron module, or one of the modules that Electron provides, that's sort of built-ins. And then from there, you can start to create render processes. And you can create 0 or more. You can create as many as you want. And that's where you have the actual user interface. And then to communicate between these, you have IPC. And IPC is basically just an event emitter. And so you can listen to an event name. How many people here have like actively used the events module from Node? OK, so a few people. OK, so the event emitter basically says, OK, I want to broadcast some information. And then you can also listen for that on that same channel, something by that same name, and you can listen for that data and then sort of fire off some kind of event. So that's a kind of sort of very high level of how it works, but you'll go find out more, I'm sure. The benefits that you're getting by using this are really actually pretty amazing. One browser. I know everybody here has at least done some browser programming where they've had to fight with IE, and probably these days you're fighting with Safari, because I guess people say Safari is the new IE. But but you do not need to think about quirks anymore, which is really nice. You have one browser, you have one implementation to deal with. You have, in order to communicate between those render processes, your front and back end, you have a plain old JSON protocol. And it can be basically whatever you want. You can send an object that has one property, or you can send a really sophisticated JSON object that has a bunch of different things in it that have meaning for you. The code reuse is pretty clear. You guys all know that there's a lot of value in the NPM ecosystem. There's tons of open source software to build your applications with. You have a single language, except your native modules. You could bring your favorite front-end development framework. So if you're really into React, or if you're really into Preact, or if you're really into Eact, or if you're really into Deact, or any of the billion different variations of React that are out there today, you can use one of those. But the point is that you can use whatever you want, or you can stay vanilla, which is really nice, and that's actually what we've done, and I'll tell you about that. But if you've ever built any native applications before for the desktop, you've probably fought with getting a GUI library together with a networking library together with all of the various libraries that you need to actually build a native application, and it's a pain. And a lot of these things really have problems kind of interacting with each other. And out of the box with Electron, you get Node's networking stack, which is really nice. The conjecture here is that basically anybody who's building web applications can build desktop applications, and they can even build really good ones. And it doesn't take a ton of, wisdom to be able to build good desktop software. So hopefully what I'm going to do is just sort of bring up some talking points that are going to make you guys feel really comfortable with diving in and feeling like you could actually achieve something that was competitive to a native desktop application. So I'm building an application with Electron, and it's a music player, and it's a store, and it's cool because it gives artists 100% of what they make in it. So it's kind of a competitor to iTunes. Okay, so I had been working on this Electron project, and it has like a lot of really sophisticated user interactions in it. And the last thing I wanted was for the application to end up with the same problems that iTunes has. And iTunes, the main problem that it has is that it sucks. And it's just not capable of providing this good user experience, and that's sort of what prompted building this application. But these are some sort of talking points from the experiences that we had actually building this application. So it kind of looks like this. There's a bunch more screens, but my co-founder is a designer, so it looks pretty good. And the idea behind it is that just keep it simple, play music, and have a nice interface for that. And the store should be really simple. And anyways, the complexity arises after you start working on something. All those use cases and all those edge cases, they sort of start to become interesting and more complex. But we started off and we just had HTML and we had CSS and we used our favorite preprocessors, and we had Jade and we had Stylus, and it was looking really good. And we put our modules in there, and the modules looked great. And they, it was so easy, and everything was just kind of working out really well. That was like the first 2 months or something like that. So you just create an index file, and you start requiring modules, and you've got a desktop app. It doesn't look very good, but things got really messy pretty quickly, because there is no sort of canonical way of developing desktop apps with Electron at this point. But I would say one of the things that really saved us was actually creating an inner node modules folder. I don't know if any of you guys have seen this pattern before, but generally when you start a project, even if it's just a front-end project, and you install some NPM modules, you have this really awesome feature in Node which says just require and then the name of the module, and the module resolution algorithm finds that module for you. So if you create a source, which is kind of lib or whatever you want to call it, and then you put a node modules folder in it, any of your code can use the same algorithm to look up modules. And this is really cool because you can write all of your sort of internal private kind of domain-specific code as if it were a module that you and your team would use. And then it can kind of graduate out of that, and it can become something that maybe you publish, and it becomes an open source module. This has happened to us tons of times. We've written code that we're like, well, this is like, let's open source this. This is awesome. People would totally use this. Our modeling, our data models, like just a ton of modules have come out of and sort of graduated out of our code base and become public modules. But this is nice while they're internal because you end up writing a README for your module, for your discrete part of your application. You end up documenting it. You end up having its own package JSON and just sort of ends up things seem pretty sensible. And I think as we've built our team, that's sort of proved our point. Is that we've had people come in and be like, "Oh, it's like a node project. I get it." So the sort of considerations to make it actually look and feel like a node, or like a good desktop application, I think, are they're actually pretty easy things. They're like, one of them is drag and drop. So if you create a new Electron application and it's got an index.html and it's got an h1 in it with a hello, and then that's all there is in there, what you'll find is if you take a file and you drag it on top of there, Electron will try to load that file. Which that doesn't feel like a native application. That shouldn't happen. That's unexpected behavior. So if you just attach an event listener to drag over and drop, and it can be a no-op, or it can actually be something that you want to do with it. Maybe when somebody drags a file on top of your application, you want to do something with it. But if you don't expect the user to do that, you should preempt that. Another really great one that we found in our beta was that you shouldn't be able to accidentally zoom the application. This is a really weird one, but if you're looking at a regular desktop application and you accidentally hit the Chrome shortcut that zooms in on the document, or the user does the pinch to zoom, and your application suddenly is like the top corner of it enhanced massively, it looks really bizarre. Oh, come in. So another one is accidental text selection. Like, there is no UI that like is a native application where you just drag the mouse around, or when you double click, you get the whole UI becomes suddenly selected. That doesn't look good. And I've actually noticed this with a lot of actually some of the apps that are pretty well put together. Commercial applications that are written in Electron, and I've either emailed people or opened pull requests to fix this, because it's annoying if you double click on something and suddenly the whole screen of text is selected. So this is the worst, though, possibly. Oh, thanks.
Can we switch to that laptop?
What? Oh, okay. This is great. So now I can kind of see this, and I can see all of these wonderful people. So yeah, render jank sucks, and like it's pretty much probably one of the most compromising things that that's going to make your application look bad. But has anyone seen the contain property in CSS yet? Has anyone been playing with that? This is really awesome. So I didn't see a lot of hands go up. So this property is great, because what this does is this informs the browser. This gives the browser some clues about how much calculations to do and when. If you insert a span into a div that is nested quite deeply in a really significantly complex document, right? And then you make a change, you know about reflow and trashing of the DOM, right? You're going to have jank. You're going to have a lot of calculations that happen totally unnecessarily. And so contain will give you the ability to specify, okay, this thing, the only thing that's going to happen in it is layout or style. And then you have some combinations of these things like strict. And there's some other settings. But I highly recommend looking into the nuances of how this tag works. It's a little bit complicated, but this is totally worth it, because for us, we've seen a lot of performance increase in areas where there is like really significantly complex nesting of document elements. So that's helped out a lot. But another one that will really help, and these are things that you can take away and you can use these in your web apps even, like these are just generally awesome for web development. Will change. Has anybody been using will change? Yeah, will change is great, right? Okay, saw more hands go up that time. So like, for instance, in our application, and I wish that we had our application here, so we have some transitions that we use, and some of these things are, they're transitions, so they're hardware accelerated, and this is pretty great, but they affect the rest of the document. And so will change gives you this ability to scope what it is that's actually going to change. So you give the browser a chance to actually optimize this. So if, for instance, you have a really large scrolling area, maybe you have, 40,000 DOM elements in it. If you give the browser a hint, it's going to perform better. It's going to try to optimize for this. And so the timeline, the timeline tab in the Chrome developer tools is really awesome. This is like your best friend if you're trying to make a UI that looks and performs really good. So in the early days of our developing Vultr, we were like, why isn't it fast? Why isn't it scrolling through 20,000 albums really fast? And we had this taglib library that is pulling out the metadata and the image from the MP3 or the FLAC file or whatever, and then it's inserting it into the DOM. It's building these little, you can see it's sort of building this album view, and it was extracting these files. Some of these files are pretty big, and so you have this DOM with maybe there's like 20,000 things in here, and actually scrolling through that many images that are fixed position inside, or that are background cover inside a div, inside another div, inside another div, inside a lot of divs, it starts to suck. And so you can see where things suck, because you get this. So who here has actually used this tool? Okay, awesome. Yes, awesome. Okay, so you guys kind of roughly know what I'm talking about here with looking for jank, and so because that many people have used it, I'm not going to talk too much more about it. And can I get a time check too? What are we at? 10? 15? 5 minutes? Okay. Oh boy. Okay. So we just talk for hours about this stuff. So yeah. So there's a cost with IPC. Which is the communication channel between the front and back end process. A lot of the time, what you would want to be diligent and put all your front end code in the render process and all your sort of back end code in the back end process. Well, that doesn't always make sense. And in our case, we actually ended up in this situation where we were like, okay, we want to read from the database, but we don't want to pay the price of actually, sending that data up through the IPC channel and then into the render process. So we actually just talk directly from our database and stream data directly into HTML, which makes it really fast. This is kind of a controversial one, and I know probably everybody here uses some kind of framework that's hot. Well, the thing is honestly, if you're up to the task, performance programming is like, you don't reach for, when you do performance programming, you don't reach for a high-level framework. Like vanilla JavaScript is really like, if your use case for developing an Electron app is like you really want it to perform awesome, and don't let it fool you, the whole virtual DOM thing. Like virtual DOM to me is like, it's almost kind of offensive in a way, because the virtual DOM in concept is like, oh well, we'll just diff it and we'll just add the nodes you need. Well, the thing is that there's actually a cost to this algorithm to do this. There's machinery involved. Now, if you want real performance, target the element you want to update and just update it. Don't have a big fancy algorithm and a whole framework to do this for you. And I'm not saying this is always true, because actually a lot of these frameworks are really great in general. But if you're doing performance programming, this I think is really important. And then, so I like to call Webpack and Browserify, I like to call these things linkers, because essentially it's doing the same job as like what the traditional compiler chain tool chain is doing. It's basically saying, okay, like you have these sort of units of code, and I'm going to put them together for you. So link your code. If you have a ton of modules in your application, like you're requiring a lot of stuff, these are all sync reads to the disk, and that can get expensive. And you want your application to start fast. And so if you kind of bundle everything up, then launch it, you're going to have a really fast, really great start times. The other thing that's really important is request idle callback. I bet everybody in here knows about that one because that one's awesome and it's been out for a while. But yeah, defer stuff if you can. And just, I love this mantra, it's just do as little as possible. Fewer moving parts, less risk. So a funny story about LevelDB. Really loved LevelDB, worked on the project a little bit, and I was like, I'm going to use LevelDB. It's a cool embedded database. It works great with Node. And so then I was like, oh, I'm an idiot because like Chrome already has this database in it, and it's actually just an IndexedDB is just an abstraction on top of LevelDB. LevelDB is already in Chrome. What am I doing requiring it as a module? Turns out that using the one that's in Chrome is like orders of magnitude slower. It was so much slower that it wasn't even worth comparing or doing some sort of like announcement about how shitty it was. It was just really, 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 really bad, the performance. So much so that like I was like, well, I'm glad that I was the idiot who tried to use LevelDB, even though Chrome has LevelDB inside it already. Yeah, and CMake is great because it's cross-platform, Windows, Linux. Memory leaks. Yeah, as JavaScripters, sometimes like there's a tendency to forget like the garbage collector is not a magical unicorn, and it's not going to save you. You're really like preparing yourself for the fact that you're going to have to deal with memory leaks is like that's just inevitable. And so you really have to pay attention to when you create a reference to something, right? I mean, we all know that how the garbage collector has a hard time with garbage collecting is when there's a reference that's held onto by, say, a closure or something like that. And so what you really need to do is think about like what references are you holding onto and why while you're writing your code. And I think that that's something that you should take away to any kind of development. But yeah, so remember to use a build tool. That's cool. Build tools are awesome when they're on Electron userland. And yeah, don't try not to call home too much. It's really annoying. No one wants an application that's chatty. Like, you know, especially like just basically like try to build for offline first when you're building a desktop application. Assume you don't have any internet. Assume no internet at all. And even better, use something like SSB or WebTorrent or one of these things where like you can actually be completely offline and you can still enjoy using the application. Connecting to the internet should just be like a bonus. And then I think it's really important to remember when you're building an Electron app, and just as you are with any kind of app that you distribute and it runs on somebody else's computer, you have access to everything. Like there's very little that you don't have access to. So you should try to be responsible and tell the user, disclose what you're doing, and write it into your docs or whatever, what you're going to touch and what you're not going to touch, and be a good citizen, software development citizen. So anyways, okay, the conclusion here is that yes, it's possible to get 60 frames per second. There's a project called HTMLGL, which is by somebody who might even be here. HTMLGL guy, are you here? Okay, well that guy's awesome, and that project is really awesome. So if you have millions of nodes and you want to render them and you want to get 60 frames per second, you should check out this project. We've been experimenting with it. Yeah, attention to pointer interactions, use a linker, design for offline first, decentralize wherever you can. Yeah, be careful about jank. And then here's some links that are really really important. This Electron userland, I think I mentioned it already. This is really, really important because there's build tools here. So when you want to package your app and put it in the App Store, or maybe you want to put it in the Google equivalent of the App Store, or the Ubuntu store, or there's like all these different stores out there that you can put software into. And there's all these tools here that'll help you do that. It'll help you code sign. It'll help you do basically all of the diligence that it takes to actually deploy an application on the platform that you're trying to target. Or maybe you're trying to target all of them like a masochist. This other one here, this guy Zeke, who is a member of the Electron team, he put together this really cool thing that that has like the really, 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 really popular packages, which is really great. So if you're starting off and you're like, oh, well, I want to do some typical thing, and it should be a module, then if you go there, you'll probably find it. And then the other thing, which is just as web developers, what we should be doing is we should be going to this Chromium link here, because this is like all of these really interesting features like will change CSS property or whatever. You can find out about this stuff here. They write really great articles about these topics, and it was just really nice because a lot of this stuff is not just in Chrome. It's everywhere. So it's like almost as good as like going to MDN or something like that. Yeah. So I don't know if there was time for Q&A or whatever, but thank you.